Hello, everyone, and welcome to eBuilding Concepts. My name is Alvin Williams, and today I am going to do a probably it's probably gonna be about two, maybe three videos, and showing the progress. But what I'm gonna create here, and let me escape out of this. Excuse me. So what I'm gonna do is I don't know if everybody recognize this particular bridge. This is the bridge that collapsed in Miami not long ago, and ultimately, what? Let me show you another photo. Okay, so going to this photo here. Okay, so I had a client ask me to create some type of what I want to say, a trade show type of model, tabletop model, to basically be a learning tool. And this particular client is a road and bridge builder. So this particular this client, I was asked to see if I can come up with some kind of conceptual model of some sort that can be used to train people on how roads and bridges are put together. So I came up with this type of folding learning center. I'm calling it, but basically, it would sit on a 6 foot by 30 inch deep table. So yeah, 30 inches this wide, six feet 6 feet this way. But yeah, it's designed to cover the entire top of the table. But what can also happen is these bridge sections can come apart in a fashion that's similar to how the bridges are constructed in real life, real size. So this model is some it's a learning tool and whatnot that and this particular client, being that they are a road and bridge constructor and resurfacer, basically these are the basically mocked up models of their different materials that'll be used to mix to make the aggregate, so to speak, for the road surfacing material. And these are models of their silos, I guess, or the mixing plant silos. So anyway, that's the gist of the model. So how this the particular bridge, going back to the photo, unfortunately, this bridge collapsed in Miami. So I had the idea to create a virtual. If we go back to the to the learning center here, what's not shown in this photo are the virtual reality goggles that people could have on to also experience this learning center. But these particular goggles, what I'm in the process of doing is attempting to a type of a type of learning virtual reality experience showing this bridge in some type of flexing or some. The workflow basically is going to be this. I'm going to take this model of this bridge, and I'm going to use it in a program that I love the most is Revit architecture. So I'm going to take the model and or I build the model in Revit. Then I'm going to send it over to another program which is called Inventor, and this is a another Autodesk product. But when I create it, once I create it in Revit and send it to Inventor, once I have it in Inventor, it's going to send it through stress analysis that will show in different colors the areas under the least and the most amount of stress. So that's the whole game plan of this thing. Is I was trying to well, being that the bridge collapsing is a major concern in any fashion or any way or shape of technology or engineering failures. This is definitely a high up on the list of bridges that have collapsed, and unfortunately killed 6 people. I believe the last I counted, I heard. So what I was thinking of doing is taking the 3D model as best as I could, get a get a mock-up in scale size in the computer of this modeled bridge, and I would like to stress it in a way using another program that will basically again, like I said, highlight the weakest and the strongest points in different shades and colors, variations to show the stresses. So wouldn't it be interesting to find out, and looking at this picture, and I haven't jotted, forgive me, I have not jotted this plan to do this down and laid out in a chronological order, so to speak, showing you step one, step two, anything. This is basically off the cuff. I just had an idea that I thought maybe would be a real good teaching tool. If nothing else, we may discover that. Let's see here. I'm gonna try to find a better picture than this, but yeah, let's use this picture here. So the place of the point where the bridge failed is this span right here is the one that collapsed, and I believe it was something they were doing to this particular web spacing or web material of the build of the bridge. They were doing something right here, and I believe this is where it collapsed. So what I was thinking, wouldn't it be interesting that when I go to model this thing up in the computer, wouldn't it be interesting? And I don't know. From this angle, it's hard saying, but just real okay. North, I believe they said the north end. So I don't know whichever end it is. I think it was here that they were doing the work and the bridge collapsed, or it was either on this one. But whichever end that it is, and I'll get that figured out later. But it'll be interesting to see if the bridge collapsed where the structural analysis program tells me it's its weakest. Wouldn't that be something? So, wow. I haven't seen anybody out there do this. Um, I just thought maybe it would be a really good experience, maybe discovering that this bridge is weak at that point to begin with. There's a lot of things or a lot of rumors going around out there as to why the bridge collapsed, and so I'm just another person throwing their 2 cents in the ring. But at the same time, what a wonderful or beautiful idea to be able to experience this in virtual reality, and it be used as a training tool of some sort, combined with all kinds of other learning experiences that can be placed inside virtual reality. So anyway, that's you're on the journey with me to get this to the point where we can actually see this thing change colors based on different types of stresses that I apply to it on the in the computer. So so that yeah, I'm hoping maybe we can get this done in half-hour segments, and max maybe three of them. So just if it's not done in this one, by the time this one ends in 30 minutes, which I don't know, I probably talked 15 minutes of it. So anyway, but you're gonna follow along with me, and if it takes more videos than that, then so be it. I'll just make more videos, right? All right. So, all right. So again, nothing's planned. I'm starting this puppy from scratch, and you guys are along for the ride with me. All right. So again, from Revit to Inventor, structural analysis, visual structural analysis. Okay. So what I already have sort of started here. Not trying to show you all of that. Okay. And let me make sure. Was there anything else I want to say leading this off? Nah. Nope, nope, nope. Okay. So, all right, I got my first program open. This is Revit. And, all right, excuse me. I just must have ate something for lunch here that's kind of coming back. But anyway, so what I've done first, kind of got ahead of making the video for a second. But I've first created a reference plane in plan view, and I was simply going to reference plane, click, and then click, stretch a reference plane out, and I named the reference plane number one. So that's as far as I got ahead of you. So anyway, now once I created that reference plane, I drew on that reference plane, and maybe I fibbed to you, but I did get a little farther. So anyway, not very much, but let me show you. So anyway, the reference plane that I drew on was on the right side, which is you see on the cube up here. It's on the east, at the east elevation. So if I go to my project browser here and click on east elevation, I'll show you elevation here, and what was not in here, and I'm going to hide it just to show you. Okay, what was not in here was the elevational plan that I just showed you, and this sketch. But what was already in here were the elevational markers that you see here, one at 0 and one at 10 feet high. So what I had to do to get this drawing is I had to import a image. Then I went and searched for an image, and the image that I happened to search for was a image that I got offline showing the plan elevational view of somewhat of the bridge. Now I do not have the full set of documents to draw this bridge out exactly the way it was supposed to be built out on the site, but I got a good amount of information with elevational views, and not only from this particular angle, but if you were to, this is an actual cut, a sectional cut of the bridge, and what you see is what it would look like if after you cut it, you would just open it up, just open it up and just look at one end of it, and this is what you would see. So that gives me a good amount of information as to the shape of the bridge, and it's not a really difficult shape to model up, as far as I'm concerned. So once I have this modeled up from this sectional cut, then it's a matter of just turning it sideways and looking at it from that angle and putting the holes. And let me show you what I'm talking about here. Let's go to there. Yeah. So when I say putting the holes in there, so the angle, the direction we were looking at was something like this right here from this sectional cut. Now, if you turn it sideways, and this is what you would see if you turned it sideways. So I apologize. I hope I'm not over explaining this to the point of boredom to people that are out there that may know this process. But I'm sure there's a lot of people out there that don't understand how things might look prospectively if you sliced it up, whether it be horizontally or vertically. But that's all this is just basically imagine taking a full item, looking at it from the side, and just cutting it right like that, and then just opening it up, and what you would see is something like this. So anyway, but what I'm going to attempt to do is I'm going to model this thing up. I'm not going to try to get it down to the exact science and make sure every nut and bolt is modeled in this. But for the for the most part, I will have modeled the major structural beam system, so to speak, that actually makes up the mass of the bridge, the main most important structures of the bridge, which is this being a truss type of design. So modeling that up and connecting all the points, and the bridge also, being that it was post tensioning cable. For all that don't know what that is, as 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 best as I can explain it in English, is post tensioning is a process where, if you look at concrete itself, concrete has an extremely high resistance to compression. So taking a block of concrete that's completely cured and putting it in my hand, and it will probably be heavy as all get out. But anyway, it has an extremely high amount of compression capability, pushing that can it can basically handle having pressed down on it without it giving in. But that's a good thing about concrete. The direction of force that it does not have very good values is tensioning. So I wish I had some kind of diagram showing tensioning and compression and what I'm talking about. But basically, concrete, if you were to grab it, and if you were strong enough to grab it on both ends of the block and just pull it apart, it would pull apart a lot easier than you could compress it. So if you get that, all right. So with that explained, the forces that are going on inside this truss to hold this bridge up, there's compression and tension, pulling apart on different members of the bridge. If yeah, this now I'm just throwing something. I'm just trying to explain it real quick. This member right here might be under compression, whereas this member over here might be under tension, depending on what's going on, how much load, and all of those things. To keep it simple, concrete needs help And post tensioning is a way of, instead of just pouring concrete in a place to do whatever, say for example build this particular truss beam. Now keep in mind, I said earlier, concrete has very good compression strengths built into it, but tension pulling apart it doesn't have. So imagine this particular beam going through a back and forth cycle of compression and tension based on what's being traveled across it, and it can withstand being compressed and hold is and with no problem. But if this beam were to experience tension being pulled apart, then once that web once that particular web fails, you try to build in redundancies to always have plan B, but this particular web might have been loaded in such a way that once it fails, then that puts extra strain on everything else. And then once the next component fails, and the next component, and then so on and so on, and before you know it, the whole thing comes down. So so yeah, basically that's what I'm going to do. I'm going to try to make sense of the bridge, and if it turns out that the thing has well designed and thought out, even though it looks, if you notice how one web on this side of the bridge kind of slants at an angle differently than the rest of them. So the each web is kind of doing its own thing, so to speak. So it'll be interesting to see what this program is going to tell me, how this bridge is going to perform under stresses. And again, like I said earlier, wouldn't it be ironic that either the bridge failed right here in real life or on this one? But either way, wouldn't it be interesting to find out if this bridge was actually already weak in the spot that it actually failed, where it's presumably failed. So anyway, so that's enough, I guess, talking on what I'm going to do here. And so yeah, nearly it's got to be close to 30 minutes already talking about it. I'll probably edit some of that earlier conversation out, just to make way for some production. But anyway, so we're gonna go ahead and start on this, and let's see here. So we got this, and again, I'm starting out with just these few basic elevational plans that I see here online. I'm gonna do my best to try to follow some kind of sense of them, but I think in the end I don't have to pay too much attention to getting it exact. I just want to be able to have a physical model to test out here, so, or I should say, 3D computerized model. I could print it out, actually make a prototype of it, even, and test it out that way. That would be a nice learning tool as well. So yeah. This project could turn into so many different things, and I just hope each one of you are join me on the ride to seeing what all can come out of this project. So all right. So without further ado, let's go ahead and minimize this. And again, this is the plan that I found online showing this particular section. So I'm going to minimize that. I'm going to get rid of that. And so anyway, so the plan is copied offline and stored onto the computer. And then the next thing was for me to import it into the program. So I would basically go up to click on image and click on that particular image that I stored, and it would bring it in here. And let me unhide that so you see it. So now once the is loaded into Revit, then it becomes a matter of getting some kind of scale of the item that you're going to create. So or use from the drawing to as a basis or trace or whatever you want to do. Um, but yeah, I want to get the model. I want to design it in the computer space at 1-to-1 scale. So everything, if it's 1 foot, 1 foot in length in real life, then it's going to be 1 foot in length in the computer. It's not. It doesn't have to be designed scaled to something else. You can do that. I have done that. You got to keep track of a lot of things when you're actually building for different types of scales and things like that. But anyway, it can be done. But we're gonna build this 1-to-1 scale, and which means the bridge is 100 on this particular span. Is 175 feet long, so I'm going to model it in the computer at 175 feet long. That's 1-to-1 scale. So, so now what I do know about the measurements of this bridge is the the dimensions that I have on a couple pages here that I printed out, and I apologize I don't have them on the screen for you to see, but it's similar to an image like this anyway. From this point of the image right here down to it looks like the center of this hole. It looks like some type of drain pipe going down the center of it. But yeah, from basically the center of that hole there, from there up to the top of this canopy is 18 feet. So knowing that, to get the drawing scaled properly, I'm gonna go to the architectural tab up here, and I'm gonna click on a model line. And remember earlier I created a plane, a reference plane. So when I go in here and choose name, click on the name, the pop down box will have that reference plane that I created, which is number one. So I click on that and hit OK. Now it's basically going to draw. What I'm going to do is, and what I apologize, I got ahead of you a little early before I started creating this video. But anyway, so what I would do before I do anything to the picture other than import the picture into Revit, I would create a a reference line at the length that I'm trying to scale the image to. So I'm trying to make sure that this point on the image is 18 feet from here down to here. So I'm going to make a line over to the side, and I'm going to make that line, you guessed it, 18 feet long. So now that line being 18 feet long, what I'm going to do is take this image, and I'm going to see, I'll tell you what I'm going to do. I'm going to do this. Yeah, I'm going to do that. I'm going to stretch the image up to that size. Now, this line that I just made is 18 feet long. And this spot here in Revit, from here to, well, I should say on the picture, we know to be 18 feet long. But if I grab the picture and drag it over to that line, you can clearly see that green line is not as long as this image, in reference to the length is concerned. So what I'm going to do is I'm going to take this line and I'm going to move it to the point on the image that I want to start the scaling from. So I'm going to choose right here. So as you can see, this line is 18 feet, but the image is showing longer than that, and we know that to be 18 feet. So to scale the image down, what I'm going to do next is I'm going to click the image. I'm going to go to my scale tool, and I'm going to click the scale tool, and I'm going to click at that starting point where the line is and where the image start at. I'm going to click one time, and then I'm going to go all the way to where the picture should be 18 feet long, but it's not. Remember, it's not 18 feet long. So I'm going to go to the point that it should be at 18. I'm going to click the second time, and then I'm going to go back to the end of that 18-foot line that I created, and then I'm going to click the third time. And what that did was that scaled that picture to reference a one-to-one scaling when you go to create the model. So again, if I'm creating this model and I use this as a reference, I have a fairly decent and accurate scale of the reference of the actual size of the bridge that I'm trying to create. So just knowing just a few measurements beforehand, I can actually reverse engineer and size, things that are with very little information given using these one of these techniques, because there's tons of them out there. So don't believe there's one way to do anything, and I'm not preaching that by any means. So this is just one particular way I like doing it. This is a program where true trust me, there is 10 million ways to skin a cat in this program. Whatever it is you're trying to do, there's the same amount of people trying to do it as well, but doing it another way. So I'll just, and as I say that, I say what I mean is there still can be right and wrong ways of doing it, and obviously the program won't act right if you're doing it an extremely wrong or difficult way. It just won't even do it. So anyway, that's what I love about the program too. It kind of makes sense the way it wants you to construct or design or build something in a computer. It follows a certain order as well in the computer, just like it would in real life, and without all the human errors of being able to track things if there's changes along the way. That's exactly what this program it does, and it does it very well. Tracks change orders. So anyway, so I got the bridge scaled, and what I'm going to do, or I should say the image scale, and now what I'm going to do is I'm going to drag this image back down to a level that makes sense for the design to begin. And if you can look at the image here, you can see the dashed lines. Those would represent the footers. In this picture portion of the picture, this would probably represent ground level. Don't let me move it. It definitely doesn't correlate with level 2 on the drawing. I'm speaking here, and let me move this over here. Okay, and get this out of the way. So we're just speaking on the image for now. So again, this level or this portion right here could very well be ground zero. So what I'm going to do is I'm going to start my modeling of this particular support column and support beam structure, so to speak, because this is what's holding the bridge up. So I'm going to actually model this support beam system, and there's another one at the other end of the bridge that I'm going to put just like this one. And those are going to be the two resting points that the ends of the bridge are going to rest on, and then we're going to flex this thing in structural analysis. So that's as much as I'm going to design. I'm not going to get into designing or modeling the cables to see if the nuts and bolts of the bridge actually were a factor in it failing. If I had that information and I wanted to actually model up every nut and bolt of the bridge, you better believe me. You better damn well believe me. This program will point out to exactly where the weak link is, and imagine if I had that kind of information. So anyway, but yeah, that's what can be done here in the computer world of it. So now that I got this image scaled, and I got actually I can get rid of that line now. There's really no need to have that, so I just clicked on it, and I'm gonna go up here and just exit out and just get rid of that line. Now I can drag the image around where I want, and what I'm going to do is, since this is ground level one right here, and then this particular beam system column goes just below that. I'm going to start my level one on my plan at the top of what's called a footer. This is to be underground and showing. Anyway, I'm going to start my image and click right here, and that's what I'm going to reference everything to that level. I'm going to draw the model and everything, and it's all going to line up with the way you see this sectional view right now. So what I got to do now is I've clicked the image, and I want to click on where I want to drag the image reference point. So I'm going to click right here in this corner, and I'm going to zoom out, and I'm going to drag this down to this corner. And notice I already drew a line in here, but that's what I'm saying. I got ahead of you earlier. So anyway, just pretend like that's not there, but and pretend I just happen to drag the image right there and click. So being that you did not see those lines a little earlier, that is yeah, you can't hardly see them anyway. So anyway, all right, so I am at the point where the image has been placed. Now I'm going to pin the image down so I don't accidentally move it by clicking on the image and going up here to the pin button. And now that the image is pinned and, so to speak, locked in place, now I can start drawing out what I want to create. Now those lines that you saw earlier, those were the lines of what's called a mass. Now I'm going to create a mass of, if you can imagine, this is going to be the support. I'm going to create a real quick mass of just that. And what I would do is go to the mass tab up here at the top, click on in place mass, and name the mask what you want to mask. Name the mask what you would like to name it. Then hit the OK button, and because I've already done it, and I'm gonna cancel out, but you would hit the OK button. And so after naming your mask what you want to name it, you draw where you want to draw by, well, what you would have is these tools here. So clicking the line tool, you can click the line tool, and now what you see popped up in the back is actually the plane, the reference plane that I drew earlier, which is called number one. This is the plane, but you can set it. If you set some other type of plane to draw on, say for example something that had a really funky angle where it wasn't straight up and down. If you remember, my reference plane was straight up and down. If you had a reference plane that was kind of at an angle a little bit, but you could see it from this direction, you could still hit the set button and then choose what plane you wanted to place whatever you drew at this viewing angle. It would place it on that plane. So anyway, we're already set at plane one, and I drew around the support beam that is going to be under the entire span of the bridge. So the measurements, the measurements came out. I mean, really, like that measurement there came out to be 2 feet. This measurement came out to be 21 feet. So when things kind of land on exact numbers like that, then that tells me that makes me feel that the scaling that I place the plan to somewhat go off of, use as a reference, that lets me know that things might make sense in the end. So, but anyway, that's just a little check and balance type of thing I have going on in my mind, just as I draw these things out. So, but anyway, as I drew around the the portion that I want to go ahead and model up first, and I actually what I did is I named this. I started out. I planned out to actually draw the bridge out. Well, you know what? Let's do this. I'm just going to clear that out, and I'm going to redraw the bridge because this is the portion of the bridge that I'm actually naming, and then the other supports down here can be named something else. So anyway, so I've undid what I worked on, and let's see what this comes out. I'm gonna stretch a line out. Let's see. Oh wow, what do you know it? That come out to be exactly 18 feet. So, and this comes out to be a weird 3 feet 2 inches, and it's at a weird angle of, yeah, let's leave it at 70 and 3 feet 2. Okay. Alrighty. So, and let's draw a center line in here so we can have something to mirror what I do on one side. I can mirror it for the other side. So let's see here. Let me get this. Now this entire bridge has a span of uh, has a span of 30 32 feet 8, or is that 31 feet 8 inches. And let me just verify that. Matter of fact, is this written in here anywhere? 31 feet 8 inches. Yep, right there. Okay, so what I want to do is make sure that what I got on this side, and I'm going to mirror it on the other side. And let me turn the image off so you can kind of see what it is that I'm doing here. Okay, well, that's right. I'm in the command mode where I'm ready to draw, and it won't let me turn image off. Yeah, it won't let me click on it or anything. So anyway, I apologize. You can't. Let me see. Maybe I can. Yeah, yeah. I really can't do anything to get that to show up better. But when I get something drawn in, you will see it. So anyway, what I'm going to do is I'm going to mirror this line using this reference center right here. I'm going to mirror it over here, and I'm going to make sure these are 31 feet 8 inches apart. And you notice that, I mean, I'm not exactly on. If I zoom, the more I zoom in on the picture, the more the line kind of looks like it's on one side as opposed to the other. I mean, if you were using this method to really get something exact, I would suggest you use some other method. This is tracing something in here. It'll get you close, but I mean, if you're really trying to locate things, you definitely want to have numbers to go by, or references, and measurements, surveying points, and things like that to use to reference where you're placing things. But again, since we're only creating a really quick, dirty model to stress and bend and see what's going on, we don't have to get that exact. So so now that I've copied this line over here. Actually, I got to double click on it, kind of. So now that I've selected just that line, I'm going to mirror that line using this center line. So it's going to place it over there, and look, it really got close. So what I'm going to do now is I'm going to take an overall measurement and just see if I'm at 31 feet 8 inches. And if not, then they'll just let me know what I have to adjust to get there. Okay, so I am 31 feet 5 1/4 inches apart. So what I'm going to do to make this real simple, I mean, just what was the chances of me being right perfect on it? So, okay, so what I'm going to do is, since I know this 31 feet 8 inches is exactly the edge, the most extreme ends of the lower part of the bridge, I'm going to cut that dimension in half. So if you got 31, and let's just pull up 31 feet 8 inches. This is the way I'm going to show you how I figure this up. 31 feet, you got 31 is okay. So you got 31 feet times 12, give you 372 inches. Then you got 372 inches plus the 8. You can't forget that 8. So you add 8 to that. You get 380 inches. Okay, so now we know in inches how far it is from one side of this bridge to the next. Now you can figure it up feet. Then you would just divide that number that you got, 380 inches, divide that by 12, and that'll give you a number in a decimal. Actually, to give you 31.666666666, which is 31 feet 8 inches. So anyway, we know we need to be 300. Let's bring the calculator back up. We need to be 380 inches from one side to the other side. We're going to divide that by 2, and we would get 190 inches. So let's see what that is in feet and inches. So let's take 190 divided by 12, and you get 15.83333, and I can tell you that is 15 feet 10 inches. So what I'm going to do is check, and I'm going to drag this witness line back over to the center that I used. And why it wait a minute, it didn't take it down far enough. There. Now, so that witness line is measuring from the center to where the line is placed, and it's at 15 feet 8 5/8 of an inches. So we want to turn that to 15 feet 10 inches. So I just click that dimension, and I'm gonna, since the whole dimension is highlighted, all you have to do is type in 15 space 10, and that's the same thing as inputting 15 feet 10 inches in Revit. Or again, if you were to input this entire measurement in inches, what you could do then is, if you do the math, 15 feet 10 inches, what was that again? Let's go back. That's 15.8333. So you could type in, well, if you typed in 15.83333, you're not gonna be able to put enough threes in there, because three just repeats over and over. So you'll never get to 15 feet 10 inches exactly. So what I mean is that you can also turn this, if you go back to 15 feet 10 inches. So let's turn 15 feet, let's turn that into inches. So that'd be 15 times 12, you got 180 inches, plus the 10, you got 190 inches. So in other words, you could actually input this as 0 feet space 190, and that'll still get you 15 feet 10 inches. So whichever way floats your boat. So that's a couple different ways right there. And now I'm going to do the same thing for this side. I'm going to make sure it's centered at 15 feet 10 inches. And you start off by clicking the actual line that you want to move. I apologize, I didn't say that earlier. You want to click on the line that you want to move first. Click on that line, or double click on that line. In this mode, you're going to double click the line, because if you only click once, you're actually highlighting the entire segment that you saw me draw in here earlier. So by double clicking on the line, now you're selecting just the line itself, and it places a witness line from the center of whatever's closest to it to the line that you're working with. And again, just like the other side of this center line, we're at 15 feet 8 inches and 8 5/8 inches. Again, we want to turn that to 1510. So since it's already highlighted, all I have to do is type in 15 space 10, hit enter, and now both of these lines are 15 feet 10 inches from this center line, this line here, and this line that you can barely see, if at all, over there. And I just clicked and shortened it. Let me take that back up and undo. Undo is going to be your friend. Sometimes clicking, yeah, I want that at 9 inches. And I'm not sure where I might have saw that. If it's 9, yeah, you know what? I do have a measurement here that's telling me how thick that is, so I don't have to guess at that. Looks like 9 and a half. Nope. Wait. 9. Oh, wouldn't that be something? Yeah, it looks like 9. Yeah, we'll leave it at 9 inches. So, all right. So since I have those, so I'm going to continue the trace, and I'm going to come to the center here, and that looks to be 15 feet 1. Now what I do know the dimension of is the thickness of this beam. So I'm going to get that number, and it says it's 1 foot 9 inches. So if you take 1 foot 9 inches, so that would be, let's do the calculator, 1 foot 9 inches, so that'd be 12 plus 9, 21 inches. So now we want to find out what's half of that, and that would be divided by 2. Excuse me. That would be 10 and a half. So let's see if we are, and now what I've clicked is the line tool again, and I'm going to type in 0, 10.5. That's the same as typing it. Oh, yeah, sometimes the program does this. I'm not sure why, but 0, 10.5 inches. That's 0 feet, 10.5 inches. So now I'm going to place. This is basically what this command just did here is when I clicked on the line to go draw a line on the screen. I was going to it basically was going to place a line exactly where I clicked and clicked to stop the line. But this offset tool, what this is going to do is offset the line where I click on the screen. It's going to offset the line exactly 10.5 inches away from where I'm drawing it. So if I do that and use the center that I created, this center line that I created down here, as I create this line, it should fall right on the edge of this beam, and then when I click the line to be placed on this side, it's going to fall on that side. So as you can see, it looks close, but it could be closer. But since I know that dimension to be what it is, I'm going to leave it alone. I'm not going to worry about it being exactly like where on the image, because the drawing that I'm looking at says the truss is 1 foot 9 inches wide. And again, like I said earlier, don't worry about being exact if you have the exact on the image per se. But if you have numbers, you go by those. So anyway, we got okay. So we got this line here that we want to attach here and go over to here and click. And now I'm going to use a tool called a trim or extend the corner. I'm going to click that tool, and what it's going to do, if you notice, this line here is all the way past this line. So if I click this line here on this side and then click this line, watch what it does. It's going to trim this line back to here. See, like that. So now all I have to do is click here, to double click to get this line highlighted, go up here to the mirror tool, and then click this center line that's down here. Now it's going to place a zap replica from this side over to this side. And you see here, this line is still longer than where this terminates. So I'm going to go to the trim extend tool again, and I'm going to click. You want to click on the sides that you want to keep. Like if I clicked here and then click this line, it would cut away this side of the line and just make a 90-degree corner here. But since I'm clicking over on this side of the line and then clicking this one, it's going to get rid of this, like so. All right. So now we can go to 3D space and observe what we've drawn so far, just to see where we're at, because again, we can't see it because it's kind of blocked out. So go to 3D space, and that's where we are. So I've drawn this, I still missed this part over here. So what I could do in 3D space, I can click and highlight these two lines, which happen to be missing over here. Highlight those lines, go to my mirror tool, click. Now I'm to click what center line I'm going to use to mirror. I'll click that line, and voila, those lines are there. You go. So you're looking straight on it now. And it's probably because that line is extending a tad bit below that one. Now I'm gonna join those corners and see, it should act as one. Now it acts as one drawing. See there? So when I run the cursor over it, but because that one line was a tad bit longer than the other one, it act as two separate drawings. So now that's where we want to be. So let's go back to the elevational view. And I know I'm way past a half hour, but I'm having fun here. So if If you guys don't mind that, we're gonna try to get this thing to a comfortable stopping point at one point or another. Who knows? Or we might go on through the whole thing. Might go through the whole thing. I mean, if you ain't got nothing else to do, I ain't got nothing else to do. All right, so we gonna. All right, so now we're gonna draw in the canopy at the top here, and I want the numbers that they give are really not the best. So I'm gonna do my best to get something here and I'm thinking they use this as a starting point. But I'm gonna, you know what? I'm gonna go across here because they got slopes in this thing that the concrete would slope down, and I could get exact like that, but it's not necessary for what it is I'm trying to show. If I were what I want to say, if I were actually the part of the NTSB, National Transportation Safety Board, if I was part of their team where I was getting paid the big bucks to dissect this thing and figure out how it failed in the computer, yeah, I would model this thing up to exactly the way it is in the real world, and we could test it out. So I'm hoping I'm hoping that the engineers did that before they built the bridge. Ooh, am I opening up a can of worms by saying that? Yeah, let's hope that they did this. This is nothing too difficult nowadays to use to find out if what's going to be built can actually stand. Anybody, God forbid, God bless them. Anybody still using the old methods of pulling out the calculator and the ruler, and oh boy, times have changed. Times have changed. I used to bash, I'm not, I shouldn't say bash, but I used to come down really hard on people that were still using AutoCAD. And that's not to say that AutoCAD isn't a great tool. It definitely was the beginning of where this all came from. But the tools that we have now, we can find out. They trust me, they can find out exactly what happened to that bridge. And if they had a lot of this information in the computer as a model beforehand, boy, and it told them exactly what they are should do to build this bridge. And for whatever reason, the bridge collapsed, but for whatever reason in the computer it showed that it would perform just fine. Then that kind of hones in on where or who screwed up. I would say, on if the computer said that it could hold, it can stand up, and that too, there too, if it depends on the skill of the 3D modelers, the people that are the technicians that are actually working the programs. A lot of their knowledge and things has a lot to do with getting accurate numbers from the computer as to what can stand, what can't stand, what will work and what won't work. That a lot of those things you do need skilled and qualified and tested and experienced people behind these programs to get that information out. So AutoCAD is limited. It's limited, and you can do. I would dare I say you can do anything with AutoCAD. Just like I feel you can do anything with Revit. You can do anything with AutoCAD, but getting there would take you an extremely long amount of time to get there, providing along the way the same information you can extract from Revit. You can get that information from AutoCAD as well, but you would have to build so much stuff into it. It would just, I just can't even imagine it. I can't even imagine trying to load AutoCAD up with the type of things you have that Revit takes care of automatically. So, without getting too far off into that, I'm gonna try to get. I'm gonna try to get another point in here to try to make sense of this circle, or what I want to say, segment of a circle, so to speak. I'm going to measure off a line from the center here, and I'm thinking they use this as a center, and see if this thing kind of creates. See, right to there, it measures 15 feet 2 inches. Now, what would it measure here? Now it's at 14.7. So that tells me the center must be down here then. So let's try down here. Let's try right there, and let's see what we get. So that says 17.4. Let's see if it says the same thing in the middle. 17. So that's not it. So could it be all the way down here? Let's see. 19.3. Let's see here. Roughly about in the middle. 19. Yeah. I think we're where this thing, where they put a center at. Let's start down here, and let's draw this circle in here. Now I could use the circle tool, or I could use this start in radius, and I'm going to use that. So I'm going to start and then end. Oh, nope, that's not the tool. Center ends arc. Okay, I'm sorry. There is a lot of options. And see, that circle doesn't quite follow. I'm wondering if the center point is clear down here somewhere. Let's try down here somewhere. Let's see if this thing matches that a little better. That looks a little better. Okay. So there's no mark down here, but maybe they split this beam in half, and somehow got. And I'm gonna try to eyeball this thing. That looks really. Yeah. Huh. It might even be further down than that. Let's try down here. Again, I'm not trying to get this thing exact, but all right. Okay, I like that. That's good enough for government work. So I'm gonna drag it over to here. Now, what I did not do is have some kind of starting point. So I'm gonna exit out of that command, and what I'm gonna do is these corners down here, based on a drawing that I have sitting in front of me, they are not marked. So, but what is marked is where this corner terminates, and they give us, they say that this this thickness of this canopy is 1 foot. Yeah, 1 foot typical. And I would bet you that these little offshoots right here are exactly 45-degree angles. So let's verify that. Let's verify and see if we can get S45 right there. And wouldn't you know it? Yep, 45-degree angles. So knowing that, and knowing that this thickness is 1 foot, and then they tell me, or I'm reading here that the dimension from the center to this inside corner here is 6 feet, 6 feet 3 inches. Yeah, 6 feet 3 inches from the corner here to the center. So we're gonna draw out another line, and we're gonna use this measurement of 6 feet 3 inches. And we're going to start in the center down here, and we're going to stretch this up here, and that's 6 feet 3. So again, you notice that it's not right on the corner, but again, I have the measurements here on a paper that tells me that's 6 feet 3 inches. And then from there, this outside corner here is at 1 foot 9 inches from this line. So I'm gonna draw. I'm gonna offset to use my offset. 1 foot 9, and I'm gonna draw a line out there. So, all right. All right. So this, okay, so the measurement, let's go to the center tool again. Oh, I want to get some I want to get some reference stop points. I really don't need that. I just needed that to measure, just make sure these offshoots were at this. So what I'm going to do is I'm going to mirror these two lines on the other side here, and by highlighting them both and clicking that center line, bam, and there you go. Both of them are now mirrored. So all right. Alrighty, so now I am, let's see here. So let's get this. Okay. So now I can offset that line to be the 1 foot typical that they speak of by just highlighting it and click. Okay. So now I know this shoots off at a 45-degree angle. And let's see here how. So it's at 1 foot 4. Let's see if we come down to, yeah, we don't quite, actually we are over a foot a little bit. So we already know this is 1 foot. So what's not lining up right here? So maybe this line needs to go up a little bit. So instead of it being 1 foot 4, let's try 1 foot 5. And let's see if that will make this terminate right at this. That's really, really, really close. Really close. So whatever, I'll tell you what. And again, we don't have to get that exact width it, Alvin. Okay, so I am just going to, okay, and then I'm gonna, yeah, I just select or placed another line there, and I'm going to join this line with this line using this corner tool, and they will intersect each other where they meet at there. So let's look at this in 3D and see what's going on. Okay, so I know I want to mirror all of this over there, so I'm going to take that and I'm going to click the mirror tool and I'm going to click right there. And now I got to do the same thing by connecting. Okay, so now I can get rid of some of these lines. I'm clean all this up. Now it's starting to look like the bridge. Pretty interesting design. All right, so go back to the elevational view here. And I want to put a break. And matter of fact, let's go back to the 3D. Okay, so I want to put a break right here, and I want to use the corner tool and join this with this, and this with this there. And I want to do the same thing down here at the bottom. Put a break. Actually, no, I don't have to put a break there. I can just click that up. And let's get rid of that. Okay, there. So now the whole thing is basically one gigantic mass that, or at least, I'm sorry, lines that can be clicked to make one huge mass. All I would have to do at this point was basically click and say how long I want it to be. So what I'm going to do is just kind of let me look at this again, just make sure I didn't skip over any feature. I don't have the railings on there, and I don't want to put the railings on there because I don't believe that they had railings. Yeah, they have the railings aren't don't offer any kind of supportive in any way to keep the bridge up. It's just a railing, so I'm not going to excuse me, I'm not going to include that in the design here. So, but anyway, if you can imagine now, looking at this end of the bridge, we basically got this shape that you see here. And then this part up here, and then it curves down, and yeah. So we have all that. We haven't poked the holes in the side of it yet, but we're about to extrude this T shape, sort of, or I shape, I beam shape, so to speak. So so yeah, they have a couple of interesting technologies going on here with this type of design, being that it's basically is the bridge is designed like a huge truss. That's all it is, and just you got your top chord of the truss for all that know what a trust is. Yeah. So this is a truss, and this is looking at the side of the bridge, and this is kind of like the web design that you would see. So that is a truss, but the chords, which this being the bottom chord of the truss and this is the top chord, the design itself. Go back here. Okay. So so yeah, the bottom chord, if you're looking at it from this angle, standing here, looking towards it, this would be the bottom chord. This would be the top chord. And notice what's going on is just like a truss, or unlike a truss, the bottom chord is just extremely wide, and it's wide enough to actually be a platform that you can walk on. So that's a bridge. So it's and there's a lot more things going on in involved in it than that. One of them being post tensioning cables that are used to hold all the concrete together and things. So I'll I will create another video showing the different ways that concrete reinforcement is used today in construction. So it's so many different ideas, and again, we're talking. This goes back to a learning center that I created for the client. That basically is all of this I want to put into VR, virtual reality, and it provides some kind of experience of of any of their brand while it's being built. So look, why don't we do this? I'm gonna go ahead and extrude this out, and we'll have a shape, and we'll go ahead and end it there. But let's and it's only because this video has to be extremely long. This thing it might be chopped up in two parts for that example, for that matter. But anyway, so to extrude this, all I would do is click here. Now I know the bridge to be 75 feet long, so by highlighting all of the perimeter features or lines that I drawn on the screen here, highlighting, clicking them all. Now I go up here to the extrude tool, and I get that. Now, right now, that is defaulted at 10 feet, and that's not long enough because the bridge we know is 175 feet long. So from the dimension that it gives me, let me know that it's 10 feet thick, and this is what I mean. But if I see that, all it did was just extrude what what was drawn. So now it's giving me a thickness of 10 feet, and I want it to be 175. So I'm going to click that 10 feet, and I'm going to type in 175 and then hit enter. And that's going to give me a 175 foot long extrusion shape like that. So that is, let's put some shading to this thing so we can. Okay. So let's see here. Let's look at the image again. So what you don't see the holes, but you see this shape. You see this shape if you're standing at the, and if these holes weren't knocked out in between the webbing, this is what it would look like right there. So again, when we come back on the next video, we're gonna knock these holes out, and we're gonna get this thing to the point where hopefully we can test it out here pretty quick. All right. So again, I thank you all for joining me on this first video, and hopefully the next ones it probably won't take long. Maybe the next one will probably wrap the thing up if it's as long as this. If you guys can hang out with me this long. I tell you, I can burn some hours on this computer here. So yeah, just join me later for follow up videos. And I thank you again for joining me here today. Again, my name is Alvin Williams with eBuilding Concepts, and I look forward to seeing you back here soon. Please subscribe. Please, if you got any comments or anything concerning anything you're working on, or if you want to talk to me about anything pertaining to building and computer conceptual modeling and 3D printing and BIM, 3D BIM, and how drones are affecting the industry, construction industry as well. You can please, by all means, leave your comments, or if you want to give me a call, 813-562-2125. Again, 813-562-2125. This is Alvin Williams with eBuilding Concepts signing off. Peace.